Okay, so at this point we have v1 squared plus v0 2 squared equals v1 squared plus v2 squared. When we plug in our values for our initial velocities, we end up with about 8 is equal to v1 squared plus v2 squared. Okay, now what we're going to do, since we already have an expression for v1 in terms of v2, is we're going to take this expression that we found in conservation of momentum and plug it into our conservation of kinetic energy equation. So we have 8.0425 equals 3.25 minus v2 squared plus v2 squared. Okay. And then we can go ahead and do out the math. 3.25 squared is about 10.56 minus 3.25 times 2, which is 6.5 v2 plus v2 squared plus v2 squared. Okay, and then we're going to have a quadratic equation. Before I start to solve it, I need to combine all my like terms and get everything over to one side of the equation. So I'm subtracting 8 from both sides. Okay, and I get 0 equals 2.52 minus 6.5 v2 plus 2 v2 squared. Okay, in terms of my quadratic equation, this is going to be my C, this guy is going to be my B, and this guy is going to be my A. Okay, so I have V2 equals negative 6.5, so 6.5 minus the square root of 6.5 squared minus 4 times 2 times 2.5 all over 2a, and since a is 2, it's really all over 4. Okay, so before I even start to do any calculations, let's think about whether I want the positive or the negative value. If we look at our picture afterwards, we know that the second object can't go through the first object, so it's not going negative. It has to be going in a positive direction. So I'm going to pick the positive quadratic solution. Okay? If I go ahead and find a number for that, I should end up with about 1.25 meters per second. Okay, now I'm going to go ahead and plug this answer into number 1, and I have V1 equals 3.25 minus 1.25 and V1 is about 2 meters per second.